So one of the things we're going to be talking about is how do we describe matter? There are certain words that we use. There's going to be a bunch of them on the list, and then I'm going to tell you in particular which ones I expect you to know. Some of them you already know just because you know English.
I don't think I have the sheet.
We're going to pause for a second. So we're going to be, some of the words you'll know already. I'll tell you which new ones I expect you to kind of hit. And then some I'm going to do, Danielle, because they're in the sciencey book. I'm not going to ask you them on the desk because they're too obscure. Because I have a dislike for memorizing useless stuff. Describing matter. Physical properties are characteristics of matter that can be observed or measured. You know what? I would underline the word physical, observed, and measured. Really measured. We're going to break these up into two types. Josh, I already kind of snuck this in earlier when we did that little Simpsons activity. We had what we called qualitative properties. They can be described, but you can't really measure them. You guys remember the other one? Also began with a Q. Quantitative properties. These can be measured numerically. You can rank it. See chart on page 22. You know what? You probably want to have page 22. And by the way, as long as one of you has it open at your table and you want to share, that works. Or you can have both of you open. But there's the chart. Let's fill them in together. So first we have some qualitative ones. Solid, liquid, or gas. What's the word that we give for that particular phenomena? State. Color is actually color, spelt with a U in Canada, so I'll spell it right. Thank you. Everyone needs a little helping hand sometimes. By the way, water is not called clear or transparent. It's called colorless because something like Coca-Cola, which is brown, is also transparent because if you hold it up, you can see through it. So just to let you know the difference, if you say something is transparent and what you really meant is has no color, I don't think it's quite what you meant. Okay. What do we call the ability to be beaten into flat sheets? Cole says our offensive line? No, no, no. We mean in science here. What do we call the ability to be beaten into flat sheets? What's that called? It's on page, isn't it on page 22 there somewhere? Yeah. Begins with the letter M? Yeah? Malleability. Make sure at the end of this I go back and I tell you to put stars next to certain ones of these, and these are the ones I'm going to emphasize. Okay. Most metal is malleable, and in fact, the more malleable metal is, gold, one of the reasons gold is so precious, yes, it's pretty, but it's also very malleable. You can make lots of stuff with it with limited technology. There's a reason why 2,000 years ago and 3,000 years ago, gold was the jewelry of choice. Pound it with a hammer, you can shape it pretty easily. What about the ability to be drawn into wires? That's, by the way, beaten into flat sheets, drawn into wire, really stretchiness, which doesn't quite, it's not the word they use. I think it begins with a D, isn't it? Ductility. Ductility. What do we call those big gray sheet metal things that air goes through? Begins with the letter D. Ducts. I kind of imagine those as long wires, and I say that's ductility. Or it's actually where the term duct tape, it's not duct tape, it's duct tape. This one, thankfully, is easy to remember. What do we call the shape or appearance of crystals? Crystallinity. Crystallinity. So if I give you that word, you'll say, oh, that has something to do with crystals. And I would also argue you already know the word color and state. So far of the 5 we've done, 2 might be new. 3 I'm going to say we can either know or figure out or already know. This next one is also pretty obvious. What do we call a tendency to be attracted to a magnet? Magnetism. All of these things, though, are difficult to attach a number to. How red is it? Oh, it's a 7. What's that mean? Right. Then there is quantitative. These are things that we can measure. And the first one is the ability to dissolve in water. If I recall, this one begins with an S. Solubility. Hey, look, 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 look. It's sort of hidden in the word dissolve. They come from the same root word. Solubility. Am I spelling it right? Oh, look, I think I am. Nope, no A there. Solubility. That looks weird with the space, Mr. Dueck. Okay, fine, fair enough. There, no one notices. Don't you wish you could do that in your paper? Yeah. The ability to conduct electricity or heat. What do we call that one? Conductivity. Okay, conductivity is both electricity but also heat as well. Conductivity. It's why most things that don't conduct electricity also make good pot holders, if you ever wondered. Because they don't conduct heat very well either. Resistance to flow. This one begins with a V. Viscosity. Viscosity. Did I spell that right? Hey, I did. In fact, later on, remind me and I'll tell you about the longest experiment in history. And it involves this. The ratio of a material's mass to its volume. Put your pencil down. Look up. This is a tough one to wrap your brain around. Thanks, Sierra. Temperature of melting / freezing. Well, we call that the melting. Okay, it's called the melting point if you're adding heat. It's called the freezing point if you're removing heat, but it will be the same temperature. So if someone says to you, object A has a melting point of 180 degrees Celsius, its freezing point is also 180 degrees Celsius, not 179, not 181, 180. It's also the temperature of boiling, condensing. Condense, how about an N? I'm going to argue these two are totally fair game because they also reinforce those 6 words that I had on that chart earlier about changes in state. Okay? I'm going to argue density is fair game. I'm going to argue solubility, conductivity, and viscosity are fair game. Now, solubility, I give you a way to dissolve. It's right in there. Conductivity, it conducts. I think that's fair game. Viscosity is a bit of a weird one. Okay. Now, for these ones, I'm going to argue state and color and crystallinity. And you know what? I'm going to ask you any one of those. Not all of them, but you need to know all those words. Mr. Dueck, you said at the beginning you weren't going to. I lied. What I wanted to do was show you, actually, you know of these, how many words are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You know 6 of them already. 3 of them you can kind of puzzle out, so really it's committing 3 here. Okay? Okay, we'll come back to that. A pure substance is a substance that is made up of only one kind of matter. And what you're going to learn this year is that there are 2 kinds of pure substances: elements and compounds. Compounds, there are trillions of in the universe. Elements, there are 121. They're sitting back there. That one's out of date. I think we've been able to create a few more in a lab. And of those 121 on that periodic table, which you'll actually learn how to read next unit, and you'll become very familiar with next unit, of that 121, hang on, pause the video. You guys are so much fun. So, some terminology, underline this word. An element is a pure substance that can't be broken down into anything smaller and separated. Gold is an element. Copper, iron is an element. Okay? Gasoline is not an element. Gasoline actually comes from combining carbon and hydrogen and oxygen. Plastics, most of the stuff that you see are not elements, but a few, like copper is, gold is, there are some very pure ones. Hydrogen is, anything on the periodic table, and you'll get a copy of the periodic table next unit. Okay? A compound is a pure substance that's composed of two or more elements combined in a specific way. So it is still a pure substance, it's just that it's made up of more than one subsubstance, more than one element. Water, H2O, two hydrogens, one oxygen, is a compound. Very useful compound. Table salt is made up of sodium and chlorine. Rust is iron and oxygen. They are compounds. Put your pencils down, look up.